Let's talk about the slope-intercept form of a linear equation. These are by far my favorite. When an equation is solved for y, it's in y equals form. We're looking at slope-intercept form. And the reason why this is so useful is because we can look at the equation and identify what the slope is and what the y-intercept is. And those two things are enough to graph a line. So the first thing I need you to understand is that m and b they represent numbers. They're going to be numbers when we're looking at an equation. The m, the first term here, has the x in it. So the m, what we call the coefficient of x, the number being multiplied by x, that will represent your slope. The b, which will also be a number, that's going to be your constant term, usually at the end, but it doesn't have to be. That b is going to represent your y-intercept. And that's very important that it's the y-intercept, not the x-intercept. Okay, so let me just give you a quick example here. What if I had the equation y equals negative 1/2 x plus 7? Okay, here's a linear equation. It has an x and a y in it. It does not have exponents, so I know it's going to graph a line when I put it on graph paper. The first term here is the one with the x in it. So the coefficient, the negative 1/2, is going to be our slope. The constant term, and don't forget to include the sign, is our y-intercept. So our y-intercept in this case is 7. And again, if we have these two things, we start by graphing the y-intercept. You have a point, use the slope to find a second point, and bam, you've got a line. Okay, but for now what we're just trying to do is make sure we understand what the slope-intercept form looks like and to be able to identify the slope and y-intercept and put it in slope-intercept form if it's not already given to us. So let's look at some examples. Okay, so I've got 4 examples here for us. The first one, I see it's in y equals, so right away I know I'm looking at slope-intercept form. I am not going to have to do any work to identify the slope and y-intercept. So the coefficient of x, in this case our variable term was first, the coefficient of x is 7. So that's going to be our slope. So the slope of this first line is 7. Our y-intercept is the constant term, the second term. So the y-intercept is 3. Okay? I look at my second example here, y equals x. This is in slope-intercept form, it's in slope-intercept form. It is solved for y equals. But this might be a little bit tricky in that you don't see any numbers. Okay, we got to think about our identity properties in this example. The first term, x, is our variable term. The coefficient of x, if we don't see it, the identity property of multiplication says it must be 1. So our slope for this line is 1. Okay, another identity property is going to help us find what the y-intercept is. If I don't see any term here, any constant term, I know that what that must be, according to the identity property, is 0. If I add 0, it won't change it. So my y-intercept in this second equation is 0. Okay, let's look at the third example. It's in y equals, so again, this is in slope-intercept form. I do not need to do any work to get it there. But I have to make sure I'm paying attention because this time they actually put the variable term second. So the coefficient of x is negative 2. So that's my slope. I don't have to move the two terms around. The commutative property of addition says I can just switch those around. It will be negative 2x plus 5. I do not have to actually move them to see what the slope is though. It's going to be negative 2, the coefficient of x. Okay, and then the y-intercept, that's going to be your constant term, the term with no variable, and if there's no sign, we know that that's positive 5. Okay, my last example here is in standard form, so this is not solved for y. Now back in Unit 2, we learned how to solve literal equations. So what I'm going to do now is solve for y. I'm going to isolate y. To do that, the first thing I'm going to do is subtract 6x from both sides. Because of the inverse property, this will help me get rid of this term right here. Okay, so be careful with this negative. It's still there. This is going to equal 0, but I still have negative 4y equals, and then this is a constant term and this is a variable term, so I cannot combine these two. So I'm just going to write the variable term first just so that it's closer to slope-intercept form, plus 20. Okay, and I just want to refresh our properties here. What we just did in this step to get from this to this, we used the subtraction property of equality. We subtracted negative 6x from both sides. So this is the subtraction property of equality. Okay, the next thing we need to do is we need to get y alone, so we need to get rid of this negative 4. So we're going to use the inverse property here of multiplication, and that is if we multiply, the opposite of it is going to be division. So if we divide this by negative 4, these will cancel out. Okay, they'll make 1, and if I multiply by 1, they just totally goes away. And to keep the equation equal, I have to divide both sides by negative 4. And when I do that, when I divide this side by negative 4, it means I'm doing it to both terms. Okay, so here, like I said, this is 1. 1 times y is just y. Y equals negative divided by negative is positive, and if I simplify this fraction, I get 3/2 times x. A positive divided by a negative is a negative, so negative 5. And again, what I just did to both sides is divided. I divided both sides by negative 4 to keep the equation equivalent. So this time I used the division property of equality. Alright, and now I've got it in slope-intercept form. I've got y equals. So now I'm ready to identify the slope and the y-intercept. So the slope is my coefficient of x here. It's 3/2. And my negative 5, don't forget the sign there. That's part of your y-intercept. Negative 5 is my y-intercept. Okay, now try some practice of your own.